Hi, my name is Markus, and in this video I'm going to show you why you shouldn't measure resistors in a circuit. So let's jump right in, and we are starting with a little experiment. So right here I have a very simple circuit. These are two resistors on a breadboard and they are connected in parallel. And now we want to measure the resistors. So I have my multimeter. It's in resistance measurement mode. The probes are already connected. So let's connect the probes to one resistor. One on the first leg and one on the second leg. And now the multimeter is measuring and it shows us a value of around 110 ohms. So let's check the other resistor also. And the second resistor also gives us a value of around 110 ohms. So if I disconnect it again and I just take one resistor out, and now we are doing the same measurement. So I'm connecting the same resistor to one of the test leads and now the second one. And now the value has doubled. It's now 220 ohms. So why does this happen? Let's check the other resistor too. And suddenly the second resistor also have a resistance of 220 ohms. So now let me explain why this happens. The reason for this is because the resistors were connected in parallel. The multimeter generates a measurement current, and this current is not only flowing through the one resistor we want to measure, but through the whole circuit. So the measurement current is divided and flows through both resistors or through the whole circuit. And this is also the reason why the measurement result is distorted. This is also the reason why we get two different values for the resistance of the same resistor. And to avoid that, we always have to make sure that we disconnect the resistor from the circuit. So for example, we can just take them out if you have a breadboard. But if they are soldered in place, we really have to unsolder them to really get the correct measurement. So now let's answer the question why the value of the resistor in the circuit was exactly half as much as the correct value of the resistor. So we have a parallel connection of the two resistors, and you can calculate the total resistance of two parallel connected resistors with the equation on the slide. So the total resistance is calculated by multiplying the two values of the resistors and then dividing it by the sum of the two resistors. And for the two resistors, you can see that we calculate a total resistance of 110 ohms. And this is exactly the amount we measured in our little experiment. So now let me show you a different option how you can measure the resistors in a circuit. So as I have explained, you have to take out the resistor to get the correct value of its resistance. But there is a second possibility. As you can see, I have put the circuit back together and we get the value of 110 ohms again. And the second possibility is to disconnect one leg of the resistor. So I just unplug one of the legs out of the circuit. As you can see, the leg is now disconnected. And if I measure the resistance right now, I also get the correct reading of 220 ohms, although one leg of the resistor is still in the circuit. So for example, if it's very complicated to get the whole resistor out of the circuit, you can just disconnect one leg and then take the measurement. This is also a possibility to get the correct reading. If you now want to learn how to measure with a multimeter from the start up, check out the link in the video description. I have created an online course where I guide you through practical measurements with your multimeter step by step, so you can learn how to use your multimeter properly. I hope to see you there, and goodbye.